Oh, all right. So we have with us Judas. Judas? You call yourself Judas? Gnostic Judas?
Yes, I do.
All right. Gnostic Judas. Master Judas. All right. Master Judas.
Judas Christ.
Judas Quest. All right. Let's discuss. Okay. So let's talk about what happened um, in the double slit experiment. What's the history of the double slit experiment? So, in the beginning, they wanted to know what is light? Is it a particle or a wave? So they knew that waves, if a normal water wave, imagine this is we're looking from the top at like a bath or a pool with water, filled with water. No, that's not gonna work. It's not gonna work. We should maybe watch a video, but it's not gonna let me show you a video, so forget it. Anyway, we know. I don't know if you know, but waves. If a wave goes through two slits, then from the other side we're gonna get an interference pattern. So if we have like a water wave, this is from the top view. So we throw a pebble, top view. Here's a pool. Oh, yeah, yeah, yeah. Maybe you should go watch it on my stream. Oh, I didn't give you the stream. That's fantastic. So I'll give you the link to the stream. I'll put it. I'm not going to put it in the side chat because it's going to move my paper over.
Okay,
So
sounds
here it
sounds
is. Here
interesting.
it's in general, so you can click the link in general to see my stream. It will probably be easier for you. So, top view of a swimming pool that the water are calm, and then we drop a pebble and we would see waves coming out, right? Waves will come out and will travel across the swimming pool. That's good. Now, if we put, let's say we put, let's draw this again. And this time we're going to put a barrier. And again, we'll drop a pebble here, and again, we're going to get waves, and of course, they're going to get blocked here, and that's the end of that. So this time, let's run another experiment, and we're going to have a hole, a slit in the pool. Again, we drop a pebble, waves come out, and as the wave hit the this hole, that what's going to happen is waves are going to come out of this side like this. That's what we notice that always happens with waves. All right. Next next experiment, we're going to take the pool, same pool. We're going to again put a barrier in the middle, but this time we're going to make two slits in the center. And again, we're going to drop a pebble and we're going to see water waves, water fronts moving. And as they go through these two holes, there's going to be one wave front coming out and another one. And these two waves are going to start interfering with each other. And we're actually going to see an interference pattern so that we'd be able to like see, I don't know exactly, but there's going to be like a line of troughs of high waves and a line of low waves, a line of high and a line of low. So if we would look at at the back of the pool, we would get high waves, low waves, high waves, low wave, high, low, high, low, high, low. Incredibly enough, that's what we get. If we ran the experiment, that's what we get. So far, do you believe me, Judas, or do you not believe me?
Yeah, I do agree. The only and it is like clear. The only part which is confusing is with the red line. I'm not sure what you mean.
Yeah,
The trough
you
and
need
stuff
to
like
see
that.
the experiment. So let me look for on YouTube. Let me look for the. Yeah, you need to see this with your own eyes. Can I share? No, I can't share. Okay, so the double slit experiment, but we want with water. Okay, that's good. The original double slit experiment from Veritasium. Too long. Double slit. We need double slit in water. Double slit in water. Water experiment. Let me find it. Okay. But is it real or simulation? I don't know. Oh, I think we saw it yesterday. Um, so let me share it with you. Let me see if this can work. The double slit experiment water. Tell me if you see it. I don't think you would see it.
Wait, one sec. Am I supposed? Is there like a YouTube video playing or something?
Stream is running. Yeah,
No, are you
running is good.
trying to show me a video or something?
You should be able to see it
Oh, what stream?
on my stream. You should
Yeah,
be able to
I,
see
I,
it.
I see now. I see.
Okay. So these two guys, let me move this to the beginning. These two guys, see, they're just tapping the water with their bare hands. Of course, YouTube stops playing. All right. They're just clapping the water. This and you it's you can basically see a line here and a line. You see these lines forming. It's difficult to see. You have to kind of squint to see it, but there's a line of low waves or whatever. There's these lines forming. There's lines, straight lines. It's not so clear.
Yeah, I
Let me
can't.
see. Oh,
Oh
this is
wait.
Veritasium. Yeah, I'm gonna switch.
Oh yeah, 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 yeah. Okay, okay, okay. Yeah, they're like, oh wow, yeah,
Let
I
me
do.
see.
Yeah,
Let me see. This
yeah,
is
I
a, I
get it.
don't. This is a simulation. See here, they're showing the lines that you're supposed to get. But this happens with water. It's just that I'm looking for
Wow,
a good experiment to
very
show it.
interesting. Okay, yeah, I see. Okay.
Yeah, but it's just because of the nature of a wave. Things that wave, they create interference patterns. When you pass a single wave through two slits, that's what happens. You just get these highs and lows. Let me see if we can play this one. Yeah. Are you gonna play? Are you gonna play? Are you gonna play? Oh my God. Jesus help me. Oh, it says I'm not gonna play. Okay, whatever. It's not gonna play. Um, this guy also is not gonna play. Why do idiots exist that don't want us to play their videos in preview mode? Oh, my experiment comes up. That's so funny.
Where? Can't see.
That's mine. That's
Oh yeah, I see. I see. Yeah,
my
yeah.
mine from 2 hours ago. That's so funny. Um, so do you believe me when I tell you that this happens? Let's see, maybe this so it's called Young's double slit experiment. And that's how they verified that, I mean, since water, we know how water waves behave, and all we checked it with all waves behave the same way, that when waves go through slits, we get an interference pattern between the two slits, between the two waves that come out of the two slits. All right, it's just something that waves do. It's no big deal. So the question was, is light a wave or is light particles? So if light is particles, you'd expect just um, two regions to light up behind the two slits if it's particles. If the light is composed of particles moving, then they should go through the slit and hit around here, and they should go through the slit and hit around here. So we should expect two regions to light up if it's a particle, if light is composed of particles. But if light travels as a wave, then we should get an interference pattern. I don't know why it's not playing. Oh, forget it.
Yeah, yeah. I need like a video, like an image or something.
Yeah, yeah, I understand. But you can learn about the double. Everybody's talking about the double slit experiment. It's like the oldest. It's the beginning of the paradoxes of quantum mechanics. This is how quantum mechanics began. They ran this experiment and they discovered that. What do you think? Did they get an interference pattern or not?
My understanding is that the what actually happened, or
Mhm.
how the light behaved, is unclear. So maybe it's contradicted our notions, and that's why it's so spooky or creepy, whatever.
Oh, but what do you think happened with the experiment? I mean, the experiment, there's only one result can show up in an experiment. Either you see two regions that light up, or many regions that light up, where the centermost ones are more lit. So the question is, for two slits, do you get two regions that are lit, or do you get more? That's the question. What do you think is the answer?
But I obviously don't know, so I'll have to guess.
Yes, you guess.
So
You're right.
maybe,
Good.
maybe sometimes there's just it lights up twice, like in two regions, and maybe other times
I'll
it's
ask you.
everywhere.
Okay, let's assume light travels as a wave. Then what do you expect to see on the detector, on the film at the back or on the board at the back? What do you expect to see if light is a wave? If light travels as a wave, then what do you expect to see to show up uh, on the backboard or wherever we display light on the display? What do you expect?
It's gonna have like a wave pattern. I mean, it's not gonna come out in two regions. It's gonna
Very
come
good.
out multi a lot, basically, all
Very
over the
good.
place.
Very good. Very good. So here you see, by the way, you see the lines. You see the lines. I think
Yeah,
the lines is where this is called an interference pattern. So this wave and this wave are interfering with each other. They're basically going through each other. They don't care for each other. But it just so happens that you just get what we call an interference pattern. They're not showing what it looks like on the back wall. We'll have to, right, they're not showing what happens at the back wall. This is the Looking Glass universe. I made a video about what she did. She did it with a laser beam, and you're right. You see them. It's going through two slits, but there is many lines coming out. She put one laser beam through two slits, and she's getting many, many, many lines, meaning she's definitely getting an interference pattern. This is a
yeah.
single beam through two slits. Why are there so many lines?
It's like peeling away, like
It's what?
cheese sticks, like peeling away from each other. Like it's not one
But
unified
why
line. It's
so
like
many? So if
yeah,
there's two slits, you'd expect, you know, it used to be one laser beam. It should become two laser beams or something. But why so many? It's really many. It's like 20, 30 lines coming out. It's all over the room. It's like from one wall to the next. Like the stronger the laser beam and the more smoke she was using, the more lines she detected. How could that be? So what's the explanation?
I wouldn't know where to start.
Why? You gave the right answer. I just want you to repeat the answer. The fact that I'm asking it again doesn't mean that you gave the wrong answer. So what's the answer? What is light? Essentially, is it composed of particles or is it composed or does it travel as a wave or as waves?
Composed of particles, photons.
Just look at the data. Here is the data in front of us. This is the data. If it's particles, why, right? It's a single laser beam, right? It's a laser. She took a laser pointer from the store for like $1 laser pointer. She put it through a two slits. She
Yeah.
put it through two slits. Just
And
two
now it's
two
acting
holes.
like a wave.
What?
Now it's acting like a wave now.
What do you mean it's like a wave? What do you mean?
Well, it's splintering off, and it's not two. What a particles should be doing. It comes out two times,
Exactly.
but it's splintering off like a wave.
Like a wave. What do you mean like a wave?
Well, waves may splinter off when they come out through the two particles.
Two particles?
The two slits. Sorry. Yeah.
Exactly. So when a wave goes through two slits, the two waves that come out of the two slits interfere with each other and create these lines that we saw with the water. So this fits the theory that light is what? What is light?
A wave.
A wave, exactly. Light is a wave. That's basically it. All right. So what's the problem? So it's clear that light is a wave. So what is the problem? What could be the problem? So the problem was that they said, "All right, that's all good. Let's now run this experiment." One, because I don't remember at what point they ran it, but they said, "Let's run it." Because I think at that point they knew already that light is also photons. I don't remember the history, but they let the light shine in a very low intensity, or maybe they used electrons. I don't know what they used. Anyway, let's say they used electrons. So electrons are like, when do you see electrons? So when you touch the door in the winter and you see that little zap, that little spark, those
Mhm.
are electrons. So would you say electrons are a particle or a wave?
Uh, I'm not sure. I guess there should be. I don't really know. Like I don't know.
Is it
Presu-
is it
Presumably,
flowing? Because a wave is
it's
propagation.
more not not
What?
really. No, it doesn't really flow. It's more just yeah. I guess particles then
Why?
because they don't flow like waves do.
It's the opposite. Flow is the opposite of a wave. A wave is the propagation of pressure waves through a medium. A wave is the propagation of energy or the propagation of pressure through a medium, through something, through a solid, through a liquid, or through a gas. Right? When I'm talking right now, I'm creating pressure waves in the air. Some of them go
Yeah,
into my desk and they move even faster inside a solid. But these are pressure waves. So, what is a spark? Is spark a wave or is it particles? Is it tiny particles or is it a wave? Is it the propagation of pressure through something?
I mean intuitively it would be a particle. The explanation you gave for wave doesn't seem to add up with the electrons, but I'm open to my intuition being wrecked.
Wait, let's bring up the black. Where's the blackboard? There used to be a blackboard. Oh, leave activity? What do you mean leave? I want to go. Where's the white? Oh, there's the whiteboard. Okay.
Uh,
Pop out, leave. Okay, here's the whiteboard. So let's talk about, is it, let's create a new one. So when you touch the door in the winter and you see the flow, I mean, okay, the lightning, is lightning a wave or is lightning the flow of particles? What does it look like?
Like
I'll remind you what a wave looks like. So a wave looks like water waves. So if you look at the pool, let's look at a puddle from the side. This is the side view of the pool. Let's say the pool. This is the side view of the pool. Here is the water surface. And if we drop a pebble in the water, then we're going to get, right, the pebble will cause the water to go down, and then we're, we're, we're going to get something like this. And there's going to be propagation of pressure or of high tide, low tide. The propagation of some energy is going to be in some direction. But every single molecule is just bobbing basically up and down. No molecule of water is traveling. There's no water motion. If there was water motion, then the water would come out of the pool. But as long as the waves are low, there's no water traveling out the pool. So this is a wave. When you touch the doorknob, you see a spark. This is like magnified 10 or 100 or 1,000 times. You see a tiny spark. Do you see a wave pattern? Is there a wave pattern? Is something waving here?
mm,
Do you see,
presumably yes. Then
you see something waving in the spark? What this is what a wave.
happened very fast. To be fair,
One second. This is what a wave looks like. A wave is something is bobbing up and down or left and right, or right. We saw with the air waves that the bobbing of the air molecules is left and right from the fork. The tuning fork was bobbing left and right, which caused the air molecules to bob left and right. With water surface waves, each molecule is bobbing up and down, and a wave is moving transversely. An air wave moves, I don't know what they call it. It's not transversely. I think they have a different name for it. Anyway, so I would say when you touch the doorknob, this is your finger. So basically, electrons that have collected inside your body are fast running, rushing into the doorknob that is it's basically detached from anything. I think the doorknob is a piece of metal that is just, it's not touching anything, so it's not grounded. So if you, by moving your feet across the carpet, you're collecting extra electrons, you're becoming you're gathering more and more and more of this negative of of these electrons. So there's an imbalance. When you come close to touch it, the electrons are they want, for some reason, this is a different discussion, the electrons want to jump over to the doorknob, but this is flow, this is a one directional flow of actual particles, of actual electrons are flying across. Also with the lightning, the sky, the clouds, I think, are full of electrons for some reason, and the ground is it's neutral, it's zero. And if the humidity is high enough or there is water, then finally the clouds can relieve this extra potential negative. All these electrons want to run over, right? Because there is maybe electrons and protons, like it's well balanced, and the clouds are not well balanced. Then when there is enough short circuit, there's enough of a pathway from the cloud to the ground, then boom, we see the electrons rushing to the ground. But it's a rush of electrons. It's a one-way rush. there's no bobbing. Nothing is bobbing in the way. There's no bobbing of water and energy flowing through. There's no bobbing of air molecules and energy flowing through. It's not a pressure wave flowing, moving, or a high tide wave moving. So, do you understand?
Hmm.
So, is what is a spark? Is it what is it? Can you explain to me what a spark is? Can you tell me in one word what a spark is? When you touch the doorknob in the winter?
In one word, no, but so the explanation you gave. So when you're walking and stuff, you're collecting electrons, and the electrons they're latching itself onto the doorknob. With the cloud example, there's a lot of electrons inside the cloud, and the electrons they're like falling really fast. Now they hit the surface of the ground. That's the
Okay.
lightning.
Okay.
Uh,
But
that
would you say a spark is a wave or is the flow of particles? Is it the flow of energy through particles or is it the flow of particles through whatever? What is it? What is a spark or what is lightning? Is it
it's
a
the flow of uh, like particles through other particles.
okay? And what is the name of the particles that are flowing?
The electrons.
Very good, very good. Perfect, perfect. And okay, that's good. So let's get back to the double slit experiment. So they had like a candle, and the candle sends off light, and they put the two slits in the way. Well, first, I mean, yeah, they put two slits. I mean, it was completely blocked off, except for two slits. So the light could go through the two slits. And they didn't know. So in the first experiment, they discovered light is a wave because they got an interference pattern. But the second experiment, what they did is they put this whole thing in a cave where it's very dark, and they put the candle really, really, really far, like 100 meters away from the double slit. So it was really far, and then there was the detection backboard at the back. So the purpose was to basically try and get one photon at a time. Like they said, is maybe light, or let's do it with electrons. So they ran the double slit experiment. They ran it with electrons. That's what they did. That's one of the things they did. So they fired electrons. We'll discuss some other time how you fire electrons. It's not that complicated. Basically, an old television is an electron gun. What you see in old televisions is electrons hitting like an electroluminous screen. It's called LCD. I don't remember LCD. What it's LCD? No, LE. No, LCD. Chris, I don't remember. Anyway, they fired what you said are electrons because you said that electrons, right? This is basically a spark. They managed to cause a spark to fly consistently to some positive screen, a screen that is positive. So all these electrons want to fly over, and this was inside a vacuum chamber because otherwise they wouldn't be able to do it. So they had a vacuum chamber, just like this is a television. This is basically a television set, an old television set. So the board is positively charged. This thing is negatively charged by a battery. You could say that there is a battery that they bought at the store that they connected. So the negative is connected to this guy, and the positive is connected to this guy. And it's a vacuum. And if the battery is strong enough, you're finally going to get sparks flying off. And you're actually going to get an electron beam flying off. All right. And then they put the double slit here. So what do you think they saw on the right side?
Uh,
So what are electrons? Do you remember what you answered in the spark? This is a spark. This,
yeah, yeah. I said there were waves. Yeah.
you said there are waves?
You asking me what
What you
an
said,
electron
what
is?
you told me a spark is. This is the discussion about the spark. Here is the spark. You
Oh
said,
yeah. Well, yeah, yeah. Okay. The spark is electrons essentially, uh, latching itself onto something else,
well, they're
basically.
jumping. The electrons are
Yeah, jump.
flowing.
Yeah, okay, yeah, jumping. Then yeah,
And they're jumping a lot of them all at once. That's why it hurts because it's like so much is happening that the friction that it's causing is hurting you. It could burn you. And
yeah.
actually, you can remove moles. I actually have a gun to remove moles. It's really very effective with tiny
Remove what?
sparks. Moles on like if you have moles like skin
Yeah, yeah, yeah.
moles on your
Oh
skin,
wow,
like
really?
little bumps, you just
Okay.
burn them off with a tiny spark with a little battery. A little battery creates these tiny sparks, and touch. You don't touch the mold. You just hover a little bit over it, so you get the spark, and
Mm-hmm.
you get smoke coming out of the mold, and that's it. It's
Yeah,
gone. It's unbelievable. It's like a $10
yeah,
gadget
yeah.
that you get on Amazon.
Really?
What?
No, I'm just in disbelief. Like wow, damn.
I know. I in the beginning I didn't know how to use it because I was touching the tip against my skin, and you just short circuit the battery. That doesn't give you a spark. You need to hover over the skin and then you get the spark. So here is the skin and here is the tip. It's a fine tip, and you get a spark just because there is a little bit of a distance, and then smoke comes out of whatever mole you have, and it burns it just a tiny bit. So you can. It's like a plastic. You become a plastic surgeon for $10, and you can fix any imperfection you have in your skin. It's unbelievable. So you see people with these moles, you can remove them perfectly. Like anyway, so yeah, so
Okay.
a spark is the motion of electrons. It's not a wave. It's the flow of something, of particles. A wave is not the flow. There's no flow of particles. A wave is the bobbing of particles, and a wave is like it's a macro illusion. You could say that a wave is like a macro illusion, uh, but there's nothing moving. There's no particles moving in a wave. You could say that there's energy moving. There's a pressure moving. A vacuum is moving. Um, I mean, but it's not particles moving. They are moving, but they're not transferring from the source of the wave to the destination of the wave. All right. So what did they do? So they used this experiment to conduct the double slit experiment. They wanted to test our electrons. Right, electrons should be what do you expect to see on the detector on the right? What do you expect to see in this
Them
experiment?
they are coming out in two directions.
Right.
Coming out the slits.
Right. You should here look at the board as if it's we're going to look from the back, and it's a television screen. So television, you're sitting here watching television. So what you're gonna get, you're expecting to get two dots because it's particles, right? What do you say, right or wrong?
Yeah, yeah. That's what I said. Yeah, I'm expecting to see them. It come out the two slits twice.
Exactly, exactly. And what they got is interference pattern. And this
Mm.
blew everybody's hats off completely. Everybody was in complete shock. Everybody was
Why?
in complete shock. Absolute shock and horror. How could this be?
Why did it behave differently?
For 100 years, no one knows. Until today, I'm going to explain it to you. Are you ready for the explanation? This is my
on
explanation.
the view.
This is my revelation, my discovery that I've heard from no one since forever. Since I heard of this experiment, I don't know, 20 years ago or more, I've been looking for an explanation. All the explanations that I got are never rested my mind, as we say. I never said, fine, that's a good explanation. And actually, no one has ever said that there is a good explanation. There's only very bad explanations. Some of them are more bad and some of them are less bad. They're all very bad. So
I'm extremely sorry to cut the conversation short, but it's 6 o'clock, so I
I
will
know,
have to be going.
I know you don't.
But I definitely
It's
want
good.
need to
It's
know the
yeah, yeah,
answer.
yeah, yeah, yeah. We'll continue. All right. I'll see you later. Take care. DM me when
And
you're
you,
ready to go. When you're ready to continue.
of course, yeah. It'll
All
be
right.
about 3 hours, so I'll be back at nine.
Perfect.
No,
Absolutely perfect.
come back.
All right, Judah. See you.
No,
Bye.
goodbye.
Goodbye. All right. So that was the introduction. We went through all the background. So we'll stop here. We'll continue when Judas is ready. Thank you, everyone. Bye for now.